Hey guys, I'm here setting up my new STV CNC Plasma table. Of course, this is not my first plasma table. I'm learning as I go. I recently upgraded to the STV, applying everything I've learned so far. So I'm going to walk you through some stuff here to help get your table set up, get you a little more efficient, make servicing it a little bit easier, and make things a little bit friendlier to work with. So the very first thing I'm going to do with the table before doing anything else is I'm going to get the legs adjusted for our height, get those installed so I can position this thing and I can get our pallet jack out of here. So this is just a standard pallet jack, and I got two 2x4s, and you can start out laying them down flat. You need the front one to be long enough to hit both of your sides, and then this one just sits underneath over here to keep it lifting level. So you can start out with your 2x4s flat, lift it up, screw your legs out, and then put your pallet jack back down, flip your 2x4 up, and work your way up that way. So my ultimate goal here is I'm going to be installing this 44-gallon trash can with a lid underneath the table to drain my water into when I'm not cutting, because I lose a ton of water to evaporation, makes the shop humid. The additive is expensive, so you don't want to lose that. And to fit that trash can, I got to lift the table 5 inches. So I went to our local metal supplier. We got 1 foot of 5x5 by quarter wall square tubing, cut that down to 3-inch lengths. So I was just doing a little bit of test fitting here. I'm going to thread out the legs, go over to the welding table and weld these guys, and then get them painted up so I don't have metal rusting against the floor if this ever gets wet, which, you know, it inevitably will get wet. So you definitely want to do a good job of painting these on the bottom side where they contact the floor. The next thing I'm going to do is search for any porosity in the welds, because we got some big ones here and those could lead to leaks eventually, and fill in any major underfill like we have here, because that's just thinner material. So that means if the metal actually rusts out, that's going to be the first thing to rust through. Another big glob of porosity right there. So I'll hit that with the welder, and then I'm going to go and paint over probably most of it, honestly, just since I got back to Nebraska with our humidity out here. This sheet metal is already starting to surface rust all over. I was just going to do like the welded areas where they remove the mill scale, but I'll probably at least at a minimum throw primer on all of it. All right, now we got all sorts of stuff going on, and I got a mess over here, but we got the legs painted, welded, bolted on. I still have to actually level the table the final time to get the water to drain. But as you can see, I went in, I did end up painting the whole pan. I thought, you know, I was going to do flat black, but that makes it really hard to see stuff, especially if you're trying to see part that's fallen into the water. So I had a can of aluminum Rust-Oleum that I've never used because it's kind of a weird paint, and I thought it would be perfect for this because it's really bright. We'll see if it holds up because it's kind of chalky and pasty, but it does dry quickly. And then the next step is, as you can see, I got a 44-gallon trash can under there. And so this guy comes with a nice flat lid, so we'll be able to store our water in there. From my math, the water should be about 33 gallons for this 4x4 table to be flush with the slats. So unfortunately, your 32-gallon trash cans are just going to be a hair shy. I did try a 40-gallon that is square. I thought it'd fit all the way into the corner, and I could put the drain all the way in the corner and get every last drop of water out. Unfortunately, the gap between the top and this rail is too small to fit the brute Rubbermaid square trash can in there. This 44-gallon, even though it's taller, you can smash it into an oval to get it in there. And it's tight, but with the 5-inch legs, I did the math just to make sure my fitting would just barely poke into the lid, so the water definitely goes inside, but I'll have enough room to be able to maneuver this and get it out. So the next step was going underneath, figuring out where I was going to put my drain, because you have these cross members, so you need to leave yourself enough room to tighten the fitting against this and have enough room so that we're inside the rigid edge of our lid. And so I got that all marked, and then I drilled from underneath just a pilot hole, came up top with a hole saw, welded a 2-inch short piece of pipe in there. This red stuff is called dye penetrant, so that's how you can do a leak test. It's basically a flat white paint on the underside, and then the red dye that's really thin oil on the top. And if you see any red dye come through, that means you have a leak. So then you have to clean it, re-weld it, and then retest. So now we have this threaded piece. And so the next step here is going to be threading on our ball valve and doing a test fit there. We'll get that sealed on with some pipe sealer. Then I can repaint this, and once that's dry, we can do a leak test, and then we're going to do some water testing, and I'll show you what I have in store for the trash can idea. So to be able to pump the water out of the trash can back into the table or outside, I had the idea to get an oversized trash can so that I could put a milk crate in the bottom to space my pump up off the bottom, so we're not sucking in that grit and that filth. And that also gives us some more water capacity, and you know, just lets more sediment settle out of your water before you pump it back up. So I'll put links for the stuff I got online. Like this sump pump came off Amazon. It sucks off the bottom, unlike my other two that I have out in my well pit, where that frequently floods and I have to keep that dry. They suck like from this level. So this is nice. It sucks from down here. It has all sorts of fitting size attachments. The biggest is the bottom, which is 1.25 inch barb. So I hopped on McMaster-Carr, got this piece of tubing for 10 bucks or 9 bucks. It's rigid, but it's flexible enough that you can bend it into shape. And the reason I went with 1.25 inch, it's the biggest fitting on here, so we'll get the highest flow rate with this. And then up here, you need like a 180, because if you would, let's say you threaded a hole into your table, like the drain, and you shoot water up, there's no telling how far up that water is going to shoot up into the sky. So I wanted to get a 180, and the cheapest, easiest thing was go to the hardware store and look at your kitchen sink drain kits. Those come in 1.5 inch mainly, but they also come in this smaller 1.25 inch size, which is perfect because the tube slides right over it. You put a hose clamp on it. So I just have this mocked up. I was getting my height figured out. A 2-foot stick, which is what they sell. You can either get 2 feet or 5 feet off McMaster. This 2 feet is going to be probably perfect. So we're going to do a test where I determine if I need to cut any height off of this milk crate so I can suck a little bit more water into the table. And then I'm actually going to use what they call these isolating clamps or cushion clamps. I'm going to drill on the back side. I'm going to drill and tap 2 holes so that it will hold this rigidly, and then if I ever need to remove anything, I'll just take this hose clamp off, slide the hose off, and then I can remove that. I did a test with this with the 5/8 garden hose. That's one of the adapters that comes with this sump pump, is just for garden hose. That filled 30, let's see, it's about 30 gallons in 4 minutes and 10 seconds. So I'm anxious to see how much quicker 1.25 inch tube does, but even at 4.5 minutes, that's perfectly acceptable for me. If that allows me to drain the table every day, that'll agitate the water, keep the algae from forming, and with the lid on top of the barrel, I should have very minimal evaporation, and I don't have to worry about all the humidity coming up into the shop. Don't have to worry about losing my water additive. And so you might think you need to have the weld perfectly flush with the table. I would not worry about that, because let's look at a couple things. you already can't scrape from here all the way over. You can't scrape that over here. The only thing you can scrape is this kind of channel right here. You're not going to get every single ounce of sludge and water out of your table when you clean it out. There's no point. It's just going to get dirty again. You might think when this thing's shiny and new that you need to keep it spotless, but that's going to wear off pretty quickly once you start using the table, and you're going to realize you're going to get it clean enough, and that little hump of weld right there is not going to hurt anything. All right, so I got the table sealed, repainted that. I put just water in up to the weld to test for leaks. Got the ball valve put in. So this seal right here is very important, because when you have water in your table, the ball valve's closed, the weld and this threaded seal are the only two places that the water could leak from. So definitely want to do a leak check on that. Make sure you have your pipe thread sealant on there. If the ball valve itself leaks, it's just going to go into your trash can. So now we're filling up the trash can with water for our timed test, and also to figure out how much of this milk crate we might have to cut off. I want to have enough water to get to the top of the slats and then partially submerge a sheet if I need to. I also want to have more capacity in case we have any evaporation, and or if we have any spills or whatever the case may be. I don't want to have this only have 33 gallons from the top to the top of the crate. And I will pretty much fill this with water up to the top of the barrel. I might use distilled water, since I don't think I'm going to have to worry about evaporation this time. Otherwise, with it evaporating, you're spending a ton of money on distilled water. But why distilled water? My water is a little bit acidic and it likes to rust stuff out. So without the plasma green or some type of additive, like here's the plasma green, I will absolutely have rusting issues. So I might buy whatever, 35 gallons of distilled water isn't even 30 bucks. So I'll probably do that. So while I'm waiting for that to fill, some of the things I have left to do, I'm going to weld some square tubing underneath to mount the plasma cutter to. I'll put probably some sheet metal or some expanded metal on top of that tubing, and then I'll get a layer of rubber to put over it, because they suggest isolating the chassis of the plasma cutter from the table. I also have to drill and tap like I showed you for this guy to mount, but I'm also going to come underneath. I'm going to take some paint off. I'm going to drill and tap a hole to thread my ground cable to, because using that clamp and just trying to clamp onto stuff that's not a good long-term move. That's okay for something temporary, but if you want a really good connection, you definitely want to have something threaded and bolted to the table. Plus the length on that ground is really excessive. You only need the minimum amount of ground cable to the table, so that just helps with electrical noise and other disturbances. And then one of the last things I'm going to do, once I actually get a sheet up on here, I'm going to weld some stops. So my stops are basically going to be just a little bit shorter than our pan, but they'll be higher than our slats. And so that way you can slide your sheet on, then you'll slide it back up against the stops. And that way I don't have to sit here and manually try to zero out the table to the sheet when I put it on. It'll just be zeroed once I hit the stops. It'll really speed things up for loading new material. So on this sump pump, I just went to the hardware store, and you can buy an on-off switch for the outlet. So this just plugs in line, and that way I'll turn the sump pump on with that switch. All right, so at this point, I'm done figuring out my hose size and all that, and I want to share this with you, because this took me quite a bit of effort and time, and it's pretty easy. All you got to do is sit back and watch and listen. So this thing can basically run 4 different hose sizes. You got your standard 5/8 garden hose, you got your larger 3/4 inch garden hose, which both of those you can find at pretty much any hardware store. Then you can go up to a 1-inch hose. You can get a 1-inch garden hose, but you pretty much have to special order those online like Amazon. You will not find those in a hardware store. You could also use 1-inch lay flat hose, and you could use 1-inch rigid clear hose. And then of course we have the biggest 1¼ inch rigid hose. So the results are actually kind of shocking if you don't understand how hose sizes affect flow rates. I recently did some experimenting with this on trying to figure out how to quickly fill up the fire truck. And a 1-inch garden hose is literally half the time or less than a 5/8 garden hose. So starting at the bottom with a 5/8 garden hose, and this will be a little bit on the low side for times because as you can see we're not quite up to the top of the slats on the table. I just threw the milk crate in there and sucked this 44-gallon trash can down until the sump pump turned off. I will have to go in, trim the milk crate down so we can suck some more water out to get this all the way full, but we're pretty dang close, so it's good enough for comparison's sake. Keep in mind this is a 4x4 table. If you are going to a larger 4x8, 5x10, or even a 20-foot long table, you're just going to have to do the math. If it's a 4x8, it's going to be double this. So this holds about 33 gallons when it's full. And by the way, as you can see now that I let water sit in the table overnight, the table's not going to stay pretty for long. So you got some weld spatter or whatever that is over there. And then all this leaching out, that's just because you have a piece of angle iron welded to a sheet. And where you have two pieces of metal sandwiched against each other, whether it's welded or bolted, unless you painted that first, there's not going to be any way to coat that and prevent that from rusting. Trying to put caulking in there or welding that, you're actually just going to make things worse, because this way, when we drain the table, eventually the water will drain out and dry out from under there. If you tried putting caulking in there, moisture would get in there, it would get trapped, and then it would make things rust out even worse and quicker. I just wanted to point it out. Not even 12 hours in with water in it, and we're already rusting everywhere. All right, so back to our results here. So a 5/8 garden hose to fill this 4x4 table up took 3 minutes 34 seconds, which I don't think is bad. If you're, setting the table up for the day, booting the computer and everything up, 3.5 minutes, 4 minutes, not bad at all. The biggest perk with the 5/8 is the water comes out really tame, really calm. Then of course, I went straight to the 1¼ hose. I want to do this as quick as possible. I think you'll be shocked. This filled this table in 42 seconds. It drained this can all the way down, 42 seconds. Lots of problems came with that though. The water coming out was so violent. Actually, first of all, the fitting slipped and I shot about 10 gallons of water all over the shop. That was a mess. Even when it shoots into the table, it just splashes everywhere. You can't keep the water in the table. The first thing I thought of when I was trying to calm the water, it's kind of like a fan shape, but I couldn't think of an object that would work. And I kept thinking, eventually thought, you know what? A vacuum cleaner, and that's what I'm thinking of. And sure enough, vacuum cleaners come an 1¼ inch size. This plugged right onto the end of the tube, and this did a perfect job of calming the 1¼ inch pipe discharge. However, you had to hold it at just the perfect angle, and if it moved at all, it started shooting out the back and out of the pan. So while something like this could definitely work, it was going to be pretty hard to secure this down in the table. Not to mention it takes up a ton of room. Plasma is probably going to end up cutting through it at some point. So I did away with that idea. So I came up with a couple things, doing a search on the internet of how to calm the water down. You'd have to come over here in the corner, cut this slat off, take a piece of tubing, weld the tube to the table, not seal welded, but just tack it down, put a cap on it, fully weld the cap on, put a nipple on top of that so that you can actually hose clamp your tube onto that guy. So that's tight. And then you would cut a hole, an opening at the bottom of the tube in the direction where you want the water to come out. That way it's not shooting out and hitting the side of your pan and then splashing up and out. And if that's not enough, apparently you can put some nylons over the end of the tube and that'll help calm it down. And then the other suggestion was to take a large kind of like car wash sponge and you could smash that inside that tube. Of course, that's restricting your flow, so that's going to increase your fill time. I still imagine you'd be able to fill this table in less than 1 minute. So I was going to do all that, but then I got to playing with actually manipulating and bending our tube. And I made the mistake. I went with the cheaper tube, which was the more rigid tube. They did have a more flexible tube on McMaster-Carr. This is like $1 or $2 more a foot. And that's what you would want, because this has to come out of here. And as you can see, you have to bend out of here and go around. This is kind of backwards because the can is going to be under the table. But if you imagine if this is under the table here, you have to bend out and come up. And our PVC pipe has to be below this tube. So you only have that much room to bend this out and then around this tube and up. Long story short, it wants to kink, or it's so rigid and tough, it just kind of pulls the sump pump over, and that's not good either. So the 1.25 inch out for me anyway. I don't need to fill it that fast. If you're doing a 5x10 table, I would imagine you'd want to make this idea work. If you're doing a 20-foot table, absolutely. Get the 1.25 inch hose and figure it out. So I went back to the drawing board, was looking at the 3/4 inch hose. It comes out calm enough. That's actually what I'm going to go with. The 1-inch hose, it was still violent enough, splashing enough. I have it in my mind that I might actually put this on a timer so that this thing can cycle once a day, just to keep that water agitated. And we'll see. If I do that, I don't want to have to worry about fittings leaking. The biggest perk with going with garden hose is the only leak point that you have is right down there where it connects to the sump pump, because we're going to run this hose straight into the table. Now, if we were using this guy, you'd also have the leak point down at the sump pump, but then you would have had one where it connects to this hose, and you would have had one here at this junction. So the 5/8 and the 3/4 inch hose are the easiest to work with, and obviously they're the easiest to bend. Now this 3/4 inch hose is a cheap Harbor Freight hose. You could get Flexzilla. Just keep in mind you're only going to use about 3 or 4 feet of this, so you're going to cut a brand new hose. And so the 3/4 inch hose is actually substantially faster than just a 5/8. You'll actually get this table filled in a flat 2.5 minutes versus that 3 minutes 34 seconds. Although the 1-inch does fill quite a bit faster than the garden hoses, it's 1:24 seconds to fill the table. So if you want to mess with trying to calm a 1-inch hose discharge down so it's not splashing everywhere, about 1.5 to 2 minutes, you can have this table completely full. So for me, 3/4 inch, 3.5 minutes to 4 minutes. That's really what my original goal was to keep it under 4 minutes for the fill time. That's enough time to basically you go turn your water switch on, turn the computer on, get everything running, get your table homed, and at that point your table should be filled. So the easiest way I could think to figure out what our fill line needs to be, just set the sump pump in the bottom of the trash can, filled our table up to where we want this table to be at a maximum height. And then just with our milk crate sitting in there upside down, we can see the water level. And that's where we're going to mark it. We're going to cut it off. And then when we flip the crate over and set the sump on top, the sump will be sitting at the current water level. So here's what I ended up with. I wanted to cut to this bottom line underneath, like the bottom side of the handle slots. I might not have as much capacity as I want. I can always come back in and cut a little bit more off later if I really need to. I did take a railroad tie plate and I zip tied it to the crate because the crate and the sump pump are light enough that I saw them floating in the barrel at a certain point. So this will at least keep the crate weighed down so that the buoyancy of the crate isn't lifting the sump pump up. And then one more quick thing. We don't want to send trash down into the barrel. So for like 39 cents at the hardware store, they have a huge selection of strainers for sinks and drains. You can take this, flip it upside down. This one is like, it looks like a big cowboy hat, which is perfect because you can sandwich it down, smash it down with the slat. So it keeps it planted. You don't have to worry about trying to hold it down with magnets. The weld also kind of keeps it in place. And that's going to keep your large debris from going down and potentially getting into that pump. Getting closer to having the trash can done, I definitely recommend getting a 1.5 inch kitchen sink drain kit. This hose, this 3/4 inch hose, was extremely hard to route through this. I had to use some silicone lube just to be able to pull it, and it was a hard pull. 1.5 inch, I don't think you'll have any problem pulling the hose through. So very simple. Just took some tin snips and came in from the edge and cut kind of a U shape, keeping it tight because the more air you let in, the more evaporation you're going to have. And then this lid, it's not domed like a lot of trash can lids. It's flat, but it does move up and down. And so we're going to probably end up adding in a really short, like 1/2 inch probably, stick out of NPT nipple, just so it goes through the lid. We don't want this sitting up above the lid. So the only other thing to do to this for now is find out where the hole is going to be, use the hole saw to poke that hole through, and then get this under the table, and then we'll move on to bolting that to the table. Now, I think some of the most helpful parts of my videos are the parts where I show my mistakes so that you don't have to make the same ones. So I made a couple here. Again, I would go with 1.5 inch on your kitchen sink pipe to make routing your hose through a lot easier. Plus, it should be easy to adjust it then if you ever do need to adjust it. When you're installing your pipe to weld into the table, I would have somebody help you. I'd start out by threading the nipple all the way into your ball valve. By the way, this ball valve is only 10 or 11 bucks at the hardware store. So if you ever do ruin this, at least it's a cheap replacement if you wipe out the ball seal. But anyway, thread this all the way onto the nipple and have someone hold it about 1/4 inch down from the bottom of the table. That gives you enough room when you do actually go to do your final installation, and you have more leverage since that'll actually be welded in place. You'll be able to tighten it pretty much all the way up to the table, which is where you're going to need it if you use this 44-gallon can. So I screwed up. I had it all figured out, and then when I went to weld it in, I kind of spaced off and forgot that I needed to have this tight up against the table. So I spaced it down about 3/4 inch, which shoved this into the lid. So I had to get a bottle jack, lift the table up so that I could position the can, take a Sharpie, trace around this so I know where to put the hole saw, and then this is just going to end up sitting inside the lid. It'll be fine because I can push down on this enough to move this into position without needing to use a bottle jack, but I also had to cut this handle off, otherwise it would hit the lid. So now I have less leverage to open my ball valve. So definitely make sure you get this nipple welded so that your ball valve can be flush with the bottom of the table. And then if you need to, you can always come in and cut off any excess from the top side. So while I'm standing here talking about how tight this is, my original idea is what I would still prefer to go with. And instead of using trash cans, I'd rather find 30-gallon drum barrels. So 55 gallon is kind of the standard drum barrel size, but that's way too tall for these tables. You'd want to use a 30 gallon. And the reason I would rather use the drum barrel instead of a trash can is because you can get a sealed lid, a sealed metal lid that can hold pressure. And the benefit of that is now we could have, let's picture these as our drum barrels here. 230 gallons so that we have enough room for 45 gallons of water for our table. So the reason we would need a sealed lid, really we only need it on the first one. You're going to have a sealed fitting in the lid, and then you'd have a piece of hose going down to the bottom and a hose going to your second bucket. Your second bucket would not have to be sealed because we're going to have our sump pump in here. That's where we're going to draw our water from. You're going to put a siphon tube from one into the other, and you're going to use a sealed connection, and then you have a piece of hose connecting it. Now that's going to do two things for us. It's going to allow us to use shorter barrels so they're a lot easier to work with under the short table. It's going to allow us to drain the table into the first tank, and since this will be pressurized, it's actually going to force the water up through the siphon tube and automatically start that siphon effect for us. So we don't have to actually go in and use a hand vacuum pump to get the fluid transferred. And then lastly, the siphon effect itself actually filters the water. So I've seen a couple things on YouTube. They try 2 and then 3 buckets. Usually the second bucket's a little bit dirty, and then if you add a third bucket, the third bucket's super clean compared to the first bucket. But that way you can put your sump pump in your second bucket. Okay, and so then when we put our sump pump in our second bucket, we're sucking out clean water. All the grit goes into the first one, like all of your slag and everything that falls through the drain. That's going to go in your first bucket. So it makes clean outs easier because then you don't have to remove the sump pump bucket. You can really just clean out the first bucket. Problem is, I was not able to find any 30-gallon buckets around here, and I'm under a time constraint right now. I got to get this table up and going this week. But if I were you and you have time, you can plan ahead. Definitely skip the 44-gallon trash can and go with 2 30-gallon drum barrels. Well, we're about ready to wrap this video up for today. I'm actually going to probably split this series up into 2 or 3 parts just on this initial setup because we're starting to drag this one out and we got a lot left to go over. But so far, our can is working awesome. It's pretty hard to see in there, but our water level is probably 2 to 3 inches from the top. So we got plenty of capacity with this 44-gallon trash can. Here's our garden hose coming up out of the trash can. Tapped 2 holes to put these cushioning clamps on to hold this guy nice and rigid. And then, sure enough, fire this thing up. Water's going everywhere. And for less than $1.50, watch this. Completely calmed down. So of course this is going to be a wear item. It's going to get gross after a while. You're going to have to replace it. You can buy a 10-pack for like $8 at the hardware store. Had a couple other ideas. I bought a T-splitter for 3/4 inch hose. You could run a piece of hose this way. You could wrap a piece of hose around that way. You could put a bunch of drill holes in there, just like a drain field hose. So it wouldn't be pressurized, and it'd evenly disperse the water out around the table. That'd be an easy solution. Another one is connect this into a PVC pipe and do the same thing. The garden hose with a T-split might be the best option because this wet sponge held against metal probably going to rust it out quicker than if you just have a piece of garden hose laying in here. So I'll probably play with this as I get some free time down the road. But for now, just look at how calm that is coming out now. And I might even actually go back and try the 1¼ inch hose and see if a sponge is enough to tame that down. But I have my doubts. So we'll just stick with this for now. In the upcoming parts of this series, I'm going to show you how to buy a computer, set that up, and get your own stand and you'll save several $100s there. I'm going to show you how I do my wire management for all the wiring that comes loosely on the table. I'm going to show you how I mount the plasma cutter itself. I'm going to show you some tips and tricks to make loading sheet metal on the table easy. So if any of that will help you, stick around, stay tuned for the upcoming parts. Thanks for watching. We'll see you next time.